know, okay? So this is from the graphical outline. They take samples, fibroblasts, reprogram them from a DMD patient. But now they're not using this for any cell-based therapy just yet, but this is kind of the proof of principle. And this is that big deletion I was talking about, up to 725 KB. KB, not base pair, that's not a typo. This isn't telling you that that gene is huge. It's massive. It's one of the, if not the biggest gene. But how in the world would you take a or partially functioning disease mutation, disease allele, and then intentionally take out a big chunk of it? But that's restoring function to the protein. That's what I want you to be thinking about. Okay, but I do want you to understand a little bit about muscular dystrophy, the molecular, well, more the cellular basis of it, and it all has to do mainly with skeletal muscle, but also cardiac muscle too, because that's the clinical problems with muscular dystrophy. All of this is just really exciting. Okay, so that deletion in the 2016 paper was the proof of principle that it would restore function partially, but then since then there have been a number of animal models. There's gene therapy, there's cell-based therapy. All of it's really, really exciting or possible. I think this is really not too long before we'll have a pretty good treatment for people with muscular dystrophy. Okay. I just discovered, okay, these are the assigned papers. This is just the preview of the young adult paper, and this is a very short, news and views or something. This is the main paper we'll discuss. This is a review article that I assigned previously. It's still useful, but this one just came out. It wasn't in print at the beginning of the semester, but I checked yesterday. It is now online. And this talks a lot more about CRISPR. It gives you a little bit more background about the disease. And this is more kind of a summary of how the disease gene was identified. It's still, you won't be tested on those details. By the way, I will get the study guide for both Tuesday and today, posted very soon, tomorrow. Okay, so what are these? Okay, I practiced this morning, but I probably still can't say it. Dystrophinopathy. I can't say it again. Muscular dystrophy. Now, the two most famous ones are Duchenne's and Becker. And this is really important to understand the difference, and this is important for understanding what they're doing in the young adult paper with that deletion. All four of these diseases are affecting the same gene, but different mutations are causing different things. We're going to be talking about the muscular dystrophy. Duchenne's is by far the most frequent, and that is severe. And it's okay, this does remind me, if there's anybody in the class that has a family member with any of the 3 genetic disorders we're going to be talking about, if you want to share it with the class, that's fine. If you don't want to share it, that's perfectly fine too. Okay. You might see some things that I do have a couple photos of patients, and I hope I just want to apologize in advance if it's upsetting to you because you know somebody like that. Okay. This is very frequent. This is actually, Duchenne's is the most frequent recessive disorder of the muscular system worldwide. Okay. Lots of boys, 400 to 600 every year just in the United States itself. Okay. Duchenne's is the severe one. It can be diagnosed as early as 4 years, and once it's diagnosed, there is no hope for the kids. They'll inevitably die early adulthood from cardiac or diaphragm problems. Most of the early symptoms are because of skeletal muscle problems, but it does affect cardiac muscle, the smooth muscle of the diaphragm too, and there's no treatment. And the best that can be done between the time of diagnosis and the time of premature death is just try to take care of them the best they can. Yes.
I don't know if you have an answer to this, but in addition to like muscular degeneration, is there a pain associated with that? I would believe that like cardiac pain occur, but
Well, that's a good question. I don't know. I would suspect there would be,
yeah.
but just the extreme discomfort. Now, there is some intellectual disability or learning delays associated. I'm not sure what Grace Yeah, that's a good question. There are some good animal models. I'll show you a couple of these. Both the mouse models, the original ones, and the dog ones. Those are all spontaneous mutations. There are some, there's pigs and rabbits. I'll show you some pictures of those. I don't have any pictures. I don't know much about the cats, but the pigs and the rabbits are both forward genetics targeting. Okay. So this is one of the examples of, this little boy. What's interesting, I mean, they have this very characteristic way because of the muscle weakness of, get themselves up off the floor. It's this very stereotyped movement, and obviously not a clinician, but if a parent or doctor ever saw a kid about that age going through this very stereotyped getting up off the floor, they'd immediately be tested for possible Duchenne's. Okay, this is just showing the different parts. Now there are other neuromuscular genetic disorders that affect different sets of muscles. And this is the pattern for both Duchenne's and Becker's. This stereotypical getting up in position is called Gower's sign. Okay. So, dystrophin is the gene that is mutated and causes both Becker's, the mild form, and Duchenne, the serious form. And it's found in muscle. So this is from that other review article. I just posted it this morning. And you'll definitely want to take a look at some of these. So this is just like a skeletal muscle. Within that, there's a bunch of myofibers. Myo just refers to muscle. Well, what connects, where a skeletal muscle has to do these contractions, it's physically moving. Well, what the dystrophin protein, this blue thing, it's a massive protein that basically anchors the cell membrane, the sarcolemma of these muscle fibers to the actin cytoskeleton. Okay. So if you don't have proper functioning here, then you start getting all kinds of degeneration of those muscle fibers, and then inflammation, and all kinds of bad things happen. Okay. And just to give you an idea of the histology, so these are histological sections of skeletal muscle from normal. So skeletal muscle is kind of bizarre because there's actually multinucleated cells. So this stain is real commonly used, HME. You get blue for any of the nuclei, and then pink for non-nuclei, everything else except the DNA. But so here's a normal person, here's a Duchenne's. Look at all that. So what happens because of degeneration in these myofibers, then you start getting this connective tissue. The myofibers are breaking down, and there's infiltration of macrophages and stuff. It's really bad. So these are the severe forms where the 4-year-old child is confined to a wheelchair. This is the milder form. I mean, it's not the same histology as the normal, but it's much milder than that. I think we'll stop there. The rest of the slides, I think you can look through on your own.